We'll start 14.5 Ecological Pyramids. You must be familiar with the shape of a pyramid. The base of a pyramid is broad and it narrows down at the apex. One gets a similar shape whether you express the food or energy relationship between organisms. At different trophic level, this relationship is expressed in terms of number, biomass, or energy. Three things: number, biomass, or energy. The base of each pyramid represents the producers or the first trophic level, while the apex represents tertiary or top level consumer. The three ecological pyramids that are usually studied are pyramid of number, pyramid of biomass, and pyramid of energy. For details, see figure 14 for A, B, C, and D. Trophic level. First, it comes pyramid of numbers in a grassland ecosystem. What is it? Is grassland ecosystem. Understand it? It's a grassland ecosystem. Oh, wow. It's a grassland ecosystem. Only 3 top carnivores are supported in an ecosystem based on the production nearly 6 million plants. See, top 3 carnivores for 6 million plants. That's the power tertiary consumer. That's not the power. They only gain that much energy. Only 3 gains the energy. Pyramid of numbers. See, primary producer base, lots of that. In a grassland ecosystem. So producers are many, consumers are less. Next one is pyramid of biomass. Shows a sharp decrease in biomass at higher trophic levels. Biomass. See. Inverted pyramid. This all were upright. Yes, this is upright. Now comes the inverted. Base is small and this one is inverted pyramid of biomass. Small standing crop biomass. It is of biomass. Understand, this is of biomass. Small standing crop of phytoplankton supports large standing crop of zooplankton. Phytoplankton are many, but they're small, so their biomass is less. So primary producers are less, and zooplankton are big. And they can share that, of course. An ideal pyramid of energy. Observe that primary producers convert only 1% of the energy in the sunlight available to them into NPP. Here, see, what is that? 10 like joule of sunlight. Now it is 10,000, only 1%, and afterwards 10% loss starts. Okay, and afterwards 10% from sunlight to primary producer, it is 1%. Energy in the sunlight available to them into net primary productivity. Any calculations of energy content, biomass and numbers has to include all organisms at that trophic level. No generalizations we make will be true if we take only a few individuals at any trophic level into account. Also, given organism may occupy more than one trophic level simultaneously. One must remember that the trophic level represents a functional level, not a species such. One must remember that trophic level represents a functional level, not a species as such. A given species may occupy more than one trophic level in the same ecosystem at the same time. A given species may occupy more than one trophic level in the same ecosystem at the same time. For example, a sparrow is a primary consumer when it eats seeds, fruits, peas, and a secondary consumer when it eats insects and worms. How seeds, fruits, peas? Primary producers, they will be primary consumers, and insects and worms are the primary consumers. For whom? Plants, and these are for sparrow. Can you work out how many trophic levels human beings function at in a food chain? Many. In most ecosystems, all the pyramids of number, of energy and biomass are upright. In most ecosystems, all the pyramids of number, biomass and energy are upright. That is, producers are more in number and biomass than the herbivores, and herbivores are more in number and biomass than the carnivores. Also, energy at a lower trophic level is always more than at a higher level. There are exceptions to this generalization. If you were to count the number of insects feeding on a big tree, what kind of pyramid would you get? Provide an estimate of the number of small birds depending on the insects, as also the number of larger birds eating the smaller. Draw the shape you would get. It's obvious. We will get this one. We have sun first. This one. This type of. Yes, this type of it will be inverted. These all are upright, but sometimes inverted in grassland, forest system. Uh, Pyramid of energy is always upright. Pyramid of energy is always. Oh shit. Pyramid of energy is always upright, can never be inverted, because when energy flows from a particular trophic level to the next trophic level, some energy is always lost, and that as heat at each step. Each bar in the energy pyramid indicates the amount of energy present at each trophic level in a given time or annually per unit area. When energy is always upright, can never be inverted, because when energy flows from a particular level to the next trophic level, some energy is always lost as a heat as at each step. Now, the pyramid of biomass in C is also generally inverted. Pyramid of biomass in C is also generally inverted because the biomass of fishes far exceeds that of phytoplankton. In number, always in number, it is always that, but biomass, it will be the problem. Sometimes it will be inverted. However, there are certain limitations of ecological pyramids, such as it does not take into account the same species belonging to two or more trophic levels. It assumes a simple food chain, not take into account the same species belonging to two or more trophic levels. It assumes a simple food chain, something that almost never exists in nature. Never exists in nature. It does not accommodate a food web. Moreover, saprophytes are not given any, even though they play a vital role in the ecosystem. Saprophytes is decomposers detritus food chain. Now comes the 14.6, that is ecological succession, and we will see in the next